Hey, remember to record today. Yay, team. All right, so today's Friday, meaning that it's the weekend. Woohoo. And you have homework coming up due next week. So any questions, feel free to pop them through email, Discord. Got office hours at 11 if you're struggling with any of the GitHub related things. So more than happy to help out if you're having issues. Yeah, I've never heard of this person either, but looks kind of music, comedy related, maybe? I'm guessing. Straight up music? I'm not sure. Have to check it out. Um, Funny rap type stuff. Cool. There's some really good comedy music groups on YouTube. Definitely got some good stuff up there. Um, yeah. So, meme artist, we are going to be talking about requirements for the next few iterations, and I'm curious, has anybody ever seen The Expert? I'm not going to play the whole 7 minutes here, but let me pop this into the chat if you want to watch it on your own time. I worked in industry for a while. I probably have mentioned that. I can't watch this whole thing anymore without cringing because of how accurate it is.
Our company has a new strategic initiative to increase market penetration, maximize brand loyalty, and enhance intangible assets. In pursuit of these objectives, we've started a new project for which we require 7 red lines. I understand your company can help us in this matter.
Of course. Walter here will be the project manager. Walter, we can do this, can't we?
Yes, of course. Anderson here is our expert in all matters related to the drawing of red lines. We've brought him along today to share his professional opinion.
Nice to meet you. Well, you all know me. This is Justine, our company's design specialist.
Hello.
We need you to draw 7 red lines, all of them strictly perpendicular, some with green ink and some with transparent. Can you do that?
No, I'm afraid
Let's not rush into any hasty answers, Anderson. The task has been set and needs to be carried out. At the end of the day, you are an expert.
the term red line implies the color of the line to be red. To draw a red line with green ink is, well, if it's not exactly impossible, it's pretty close to being impossible.
What does that even mean? Impossible.
I mean, it is possible there are some people, say, suffering from color blindness, for whom the color of the lines doesn't really make a difference. But I'm quite sure that the target audience of your project doesn't consist solely of such people.
So in principle, this is possible.
I'll simplify.
Yes. Red lines that are green. It goes way off the rails. They get into the fact that you can't have 7 perpendicular lines even. It's pretty good. I highly recommend checking it out. This is a good example of a customer and an internal meeting where you're starting a project. You have your engineer, you have your project manager who has no idea what they're doing, and you have your upper level management, your marketing, and the person who's actually telling you what reality is. Like I mentioned, it's painfully representative of the real world. So check that out, and try not to cry at your future. He said, only slightly sarcastically. Anyway, let's talk about requirements. And let's get a red pointer. Now, requirements is going to be a very important part of the software engineering process. So these are the things which tell your team what to make and how to make, well, not necessarily how to make it, but it's going to give them the framework to create the implementation. And there's some very key concepts that we have to take here and how we write our requirements and how we define them. There is a good chance that if you go into any kind of software engineering role, you might have to be the one defining the requirements. That makes you the analyst. So we'll talk about what an analyst does. That doesn't necessarily mean that you can't write the program, but it just kind of depends on what roles you end up playing in your company. I know in my grad class, A lot of the teams that are in industry that the students work on are very small, so people will play multiple roles. So you might have to do this aspect and code and do some testing, and it basically all becomes kind of a blur, depending on what your, again, size of your unit is. So we're going to talk about why they're so important and why we're talking about this on a beautiful sunny Friday. And we're going to go through the different types of requirements. So we have functional, non-functional requirements. There's key differences here. They're both important. You will have to define them both, right? And then we'll go through the whole process of everything as well. Because it's not just as simple as writing it down, we have to have a process naturally. So here's a wonderful quote about requirements. I'll give you a moment to read it rather than reading it to you. But the key here is to get the point across of how important this step is. And me, as somebody who I like to do a lot of hobby programming just for fun, projects that never see the light of day, I probably spend a good chunk of time writing not formal requirements, but I'll try to spec out the system with some kind of a requirement spec of what I want it to do. And then I'll sit down and start doing the work of actually programming it, and I never finish everything. So, can anybody maybe guess why this last sentence especially is so important? So no other part of the work cripples the resulting system if it's done wrong. No other part is more difficult to rectify later. Why is this statement there? I will say this is absolutely true. Anybody have a guess? Think about maybe the processes that we've talked about so far. Requirements define what you're building, so if you do them wrong, you build the wrong thing. Absolutely. So these are, I've mentioned, I think, a handful of times as we go, these are prose natural language requirements, right? Written in whatever language your team speaks. So English, German, whatever company you end up working for. I assume if we stay in North America, it'll probably be English. But if you mess this part up, nobody's going to know it's a program. The problem with this is that it feeds forward and backwards too. So your requirements will feed into your implementation, which is common sense, right? That's what you're going to build. But that also feeds in your testing, into your verification, into your customer side of things. So basically, these requirements are kind of the key linchpin for the whole process. And if we screw them up, it's hard to go back and fix them depending on your software design process. Right? If you go waterfall, you have to restart the whole thing. You have to go through all of those steps over again. If you do something more agile, it's possible to change them. However, it's still problematic. Right? We have to go back and redefine our user stories, for instance, or we have to do more sprints. There's always going to be some kind of feedback loop here that we're going to have to take care of. Uh, you're the lucky ones. My afternoon class doesn't get the visitors. Okay, so I've got a glass window right here too, which is kind of fun. I can see them running around. All right, so what are requirements? These things are, okay, go away. Okay, I'm enabling now. All right, so these are effectively written capabilities for what our system has to do, right? So we have some formal language here. So we're going to have a functionality and a constraint. So This might be some feature that we're working on. Here's exactly what it does. It might be a constraint. This system has to operate within a certain boundary, right? So for instance, if we have, say, we're testing a piece of hardware, it has to operate within 3.3 volts and 5 volts. Otherwise, it'll go out of tolerance. Or you might have a bit of software running in a real-time operating system where it has to deliver its functionality within 10 microseconds. And why is this important? Well, if you miss that deadline, then that screws everything else up in your real-time operating system. And those of you that have no idea what a real-time operating system is, that is basically it's where you don't have a formalized OS on like an embedded system or a microcomputer, where you're in charge of scheduling all programming tasks. It's very, very good for things that have to happen in real time. If you're using something that runs Linux or Windows or whatever, you're allowing the operating system to handle all of that, and it doesn't always do what you want it to, right? It thinks other tasks are important. So anyway, back to requirements, we have these two kind of key aspects to them. What is it doing, or what should it be doing within this particular tolerance, for instance? So these are specs of what we're implementing, right? They're descriptions. Again, they're written in natural language. They can be constraints. Effectively, these tell us what to do, what to test, what to build, and what we're going to be delivering later on. Now, they are also not strictly, it's going to be a day, I hear. They're not strictly sentences. They're also going to turn into objects in our system as well. So you will write them down, and you all will for probably your next homework. I'll have you define some. They will become like enumerated items. And if we were in a environment where we were using like a formal system for requirements management, these would be actual objects that you can link to other artifacts. Right, so I'm getting a little bit ahead of myself here, but if you have like something, requirement 1, do this, right? We would link that requirement to a piece of code. That piece of code would be linked to a test case. That test case would be linked to whatever we're going to link to, right? We could link it back to the architecture level. So the key thing here is that these requirements, again, these are the commonality between everything. Right? We talked about configuration management. We had tasks in our system, right? I would go make a change or a bug fix or a new feature that would be tied to a task so that I have a reason for making this change. That task is tied to a project. That project might be tied to a list of requirements. So it just depends on your configuration management system. The point here that I'm really trying to get across is how important this process is for any real system. All right, so we have different levels of requirements. We have levels and we have types. Right now we're talking about the levels. The types we'll talk about momentarily. So first we have the high level, so the customer or the business level. Business requirements are not telling your system what to do. They're focusing on the business side of things. And there's a very clear distinction here where this is not strictly something the software developer, the person doing the implementation is necessarily going to have to deal with this too much. But you're basically trying to define something in the realm of like the customer needs information from our product, or we have to provide such and such a functionality to our users. All right, so very high level. So this is like a vision or a scope document type of thing where we're trying to conceptualize our system and how it impacts the business. All right, so this is very high level requirements. These would be inside of something like a system proposal, where you're giving the high level, again, business level requirements of the system. Then we go down a little bit to the user level. Now the user level is going to be requirements that impacts the user, right? How does the user interact with the system? What kinds of features can the user expect to have? So again, things that not the customer, not necessarily your team, but what is the user going to have to deal with? We may see these manifest in use cases, which we'll talk about probably next time, where we have effectively high-level, almost goals of what the system is supposed to be doing. Or it might be quality attributes, so how well is the system supposed to perform for the user? So we can define user-specific things in our requirements as well. All right, and then we have the implementation level. So this is where we get into the technical nitty-gritty. So these are going to be functional and non-functional requirements, and these are two very key terms that we're going to be talking about in greater detail in the next couple of slides. These are going to go into a document called your Software Requirements Specification, or your SRS. This typically is a very big document, and this is where we detail all the technical aspects of everything that you're building. All right, all the features, all of the concepts, all of the constraints, everything's going to go into this SRS. Commonly in software engineering courses, the final product, the final thing that you do would be like a 100-page SRS. When I was a TA, when I was a PhD student years and years ago, I had to grade everybody's SRS, and it was awful because there was just so much paper. But it's one of the most important things that you have to work on as a developer. And if you're not the analyst, you may still have some feedback here, right? This requirement doesn't make sense, or we cannot implement this without adding a bunch of other things. So again, very important concept that we have here. So this slide basically just breaks down kind of what the different types of the levels of requirements are that we have to deal with. So again, business is high level, user requirements are user related effectively, and then our functionals and non-functionals are more technical. All right, so first, on this slide, we have our functional requirements. First time we actually have a definition of them. And the spoiler here is that functional requirements are very highly measurable. So they're very concrete. They are very easy to test. Okay, we're describing a very specific aspect of our system, and we have a very straightforward way of making sure that requirement is being realized. Does that point make sense? I keep doing this at the camera like I'm pointing at all of you, but this is a very hard and firm type of requirement. In this bullet here, it's a little more high level, right? So it's a functionality we must build to enable users to accomplish their tasks and to satisfy the business goals. Okay, that doesn't mean anything other than we rate these to satisfy these. But functional are effectively going to be behavioral requirements, represent features, represent specific constraints. So again, the key here is that they are very specific. A lot of them will have hard numbers inside of them. But does this concept make sense more or less? This is where in a normal classroom I would stare at all of you, see who's awake, who's not awake, who's on Twitch or Reddit or YouTube. Everybody's like, oh, he's looking at me. Exactly. Hey, at least you're honest. Can you give an example of this? Makes sense to me. Yeah, so let's go back to what I was talking about earlier. So we have a function that has to execute within 10 milliseconds. So its upper bound is 10 milliseconds. That would be a good functional requirement. Or if you have a function where maybe you're analyzing some data, right? It has to return a value that is Boolean, or it has to return, a range of a particular units of measurement, for instance. Or if I'm writing a game, my character cannot leave the edge of the screen because that's where the map boundary is. So again, things that we can test. So think of it that way. It's going to become a little bit more obvious when we talk about non-functionals next. So if this doesn't necessarily make sense, because you think, well, he's full of shit. We can test everything, right? Fair enough. Let's talk about the non-functionals, and then hopefully this makes a little bit more sense. So the non-functional type of requirements are more quality. So these are what are colloquially known as the ilities. So quality, security, usability, um, performance, but performability. So basically maintainability, things that are hard to measure without, something like a user study or something like that. So these are your quality attributes. These are going to be how well is the system performing, or the system should be responsive. I guess I should say maybe performance is a better term, since responsive means something very specific to web development. Um, the system should be very secure. Okay, well, what does that mean? That's not something you can test without more constraints on it, right? And then you get into the functional realm. So we're getting into kind of these are nebulous, kind of fluffy requirements. They're very, very important. I will say that. So again, these are going to define quality of the system. These tend to be very critical. So this gives you a notion of kind of what the system should express to the user. So, does the difference make a little bit more sense, hopefully? Key takeaway, functional requirements, you can very easily write test cases for them. You can very easily write unit tests or integration tests or anything like that. Non-functional, it's possible to test them, but it's a lot harder. So you're going to have to write these in such a way that they are something that is testable. And when I say test, I know we haven't really gotten to testing, and I can't really assume that any of you have ever done any testing before, but a good test is basically saying it's trying to find bugs in your program, right? And you have the lowest level, which is your unit test. Does your function return the correct values, right? Does your program block parse out a statement correctly? All right, so very fine-grained, nitty-gritty types of testing. Little blocks of code that we're trying to verify here. You get up to the integration level of testing where you have different components and you start sticking them together. Well, does the system still function correctly or not? We have test cases to see, does the behavior still make sense? Is everything still functioning appropriately? Then you get to the system level where you put everything together, and then you get to the customer level where you have even more tests happening. All of these notions of this is essentially validation, is what it's called. They're going to be tied to these types of requirements. So they have to be very specific. Okay, so high level, functional will tell you what the system does. Non-functional will tell you criteria about the system or how it does it. So the niceties, in a way, of the system. So I've given you a couple of examples, like we have to operate in a particular voltage range, or a function has to return a particular value, or a type, or something of that nature. Non-functionals, performance, maybe our system has to handle a number of user devices if we're doing like a web application or a phone application. Or we're not specifying which devices or screen sizes or anything like that. That'd be more detailed. We can maybe try to be a little bit more generic with them. Anybody have any other examples that maybe they could think of? I really hope there's not something going on in the world right now because my phone is just blowing up. Maybe like a specific method of storing data. Oh yeah, that's a good one. Sure. So we need to store user input in, a local database. Sure. So rather than just having user data float, we have to have an intelligent way of storing it. We would have maybe requirements along with that, where it's not just one, but we would drill down. We have to sanitize our data coming in, right? So we're not going to allow any kind of cross-site scripting attack or any kind of SQL injection attacks. Absolutely, sure. The key thing with requirements, and I want to make sure I mention this before I forget, you do not put implementation details in requirements. So that's a key thing with these artifacts. You don't tell the programmer specific implementation details. You let them work that out, right? So here you're taking a step back to almost the analyst role. The programmer knows what they have to do, right? You don't tell them they have to write a function in C. You tell them they have to write a function to handle this data, basically. You don't tell them to use an SQL database. They will have whatever they're going to need for their job. Right? If you're doing machine learning, you don't tell them use TensorFlow. Maybe they prefer PyTorch, or they prefer what are some of the other machine learning libraries like Orange, or anyway. Basically, you leave implementation details for further down the line. Okay, so hopefully that makes sense because we're going to keep talking about this. So here I actually have two figures. I've tried to delineate them with boundaries here. But on the left would be an example table of contents for one of those software requirement specs. So again, it's kind of a big document. So you'll have an intro with high-level things like the purpose, who's supposed to read it, what the scope of your project is, basically everything that you need to know about this document. Then you have high-level notions. So features of the product, what are some of the classes, what environment should it operate in, any assumptions or dependencies your project will have. And then you get into the requirements. So here's your functional requirements. Non-functional requirements later on where it's even broken down into categories. So performance, safety, security. These days I got to learn how to have this thing not pop up right on top of what I want to show you. Interfaces. So do we have any external dependencies? So do we have like a RESTful API we have to talk to? Or do we have to sling data over to the customer's database? All this is basically showing you is that this document is huge. And there's basically going to be some text in there describing each section and then a whole bunch of bullets describing each and every feature. And so here we have an example for some safety constraints for an adaptive cruise control system. And this is basically, it's where you have cruise control in a car, but adaptive means that if the car in front of you slows down, you slow down too. So software requirement 1.1, ACC controller should provide acceleration signal when the target vehicle is no longer in the lane. So this is telling us to keep our acceleration active, right? So we're not going to get rid of it. Controller should not increase speed when the distance to the target vehicle is too close. So we have some flexibility here, right? What does too close mean? I don't know. But that's going to be something that would be configurable later on, right? So what is your tolerance for closeness? Is it a meter? Is it 10 meters? A lot of these will be done in metric, by the way. This could be something controllable by the user, making it tied to a user requirement later on. So key here is that, again, it's in prose. You're giving an idea of what the feature is without doing too much detail. And I'm not necessarily trying to hammer on this point and bore you out of your minds, but very important, even if it is one of the driest topics in the world. Hopefully you can at least appreciate that for a business or even a hobby project, these kinds of things are super helpful. All right, and now I could not find a clear picture of this image, so I apologize for the blurriness. This was posted on like nearly every cubicle wall when I was in industry. And this is describing effectively software requirements. I get a kick out of it, even if it is a little bit cringy after seeing it so many times. But I get a kick out of this one. And if anybody can find me a nice, crisp, clear image, Google Images was failing me when I was looking for it. But how the customer explained it, how our project lead explained it, how the analyst described it, how the programmer designed it. So just your different viewpoints of what requirements are for a system, right? Everybody has a different viewpoint. And obviously this is kind of cheeky and funny, but yeah, at the end of the day, this is pretty accurate to help people understand requirements, right? Because you're all going to have different viewpoints on what somebody's telling you. All right, so you have the high level. We know the differences between our requirements, hopefully at this point. Now let's break down the different types of non-functionals that we have. Again, non-functionals are kind of important to describe the quality of your system and the content of your system. And sorry, I'm just making sure that my mic didn't cut out because I forgot that I muted it earlier. All right, so non-functionals, we have this kind of a tree where we're going to break it down. So high-level non-functional requirements, this would be one of your SRS sections. All right, we can break it down into product-specific requirements, organizational-specific, and external requirements. So organizational, these are going to be things related to your business, effectively, or things related to the organization of the project. So we have basically multiple aspects here. Actually, we're going to drill down into this, so I'm not going to bore you to tears with the high level explanation and then continue on with it. But let's talk about the product requirements. So again, non-functional, the quality side of things. What are the usability requirements for the project, right? How are people going to use it? Do we have to make it accessible, right? What kind of user experience are we going to get, depending on the type of project? This one's kind of fun to think about because usability you think of in terms of something like a web application, right, or a phone application or a game. If you're presenting lots of colors, right? If you're presenting colors, how do colorblind people see your game? So there's a lot of notion into usability that also features in with kind of more standard systems. So that ACC example we used earlier, everybody has a different preference for how close you're following another car, right? I'm comfortable with being right behind a car because I came out of the Detroit area and we drive like mad people over there. Maybe on this side of the state, we're a little bit more spread out, right? So usability is not just, handling different people's abilities to use technology. It's almost also your comfort level, right? It's also how you want the system to feel while you're using it. And that is a whole other area of software engineering and software development. Yeah, so then you talk about efficiency. Efficiency can mean multiple things as well, right? It can be how fast your program runs, how well it runs, what kind of space it takes up. So obviously space requirements are things that developers don't seem to care about anymore. When you get, massively bloated like JavaScript applications or games that require 100 gigabytes of information. So these types of requirements will factor in as well. Need to move downstairs today, apparently. Then we also have our reliability requirements, right? So how well does this thing perform over time? How reliable is it? Can we trust it? If you're building an autonomous car, reliability would be a very, very important requirement to have. Otherwise you crash into the wall or you run somebody over by accident, right? Reliability is super important. We also have portability. Can I take my program build it once, say you're doing something in Unity or Godot or any of these cool new transpiling technologies. I build it for Windows, then I have a build for Linux, OS X, sorry, Mac OS, I keep forgetting that. I have a build for the web, Android, Apple. How portable is this thing? Can we port it to a calculator if we're going down the Doom path for portability? Right, so that's our product branch. We also have the organizational side of things, and again, this is related to kind of business level requirements. What are requirements for delivering the thing? Do we have standards that we have to follow? Or we might be following a particular auditor's requirement, so we might have to be ISO certified or TS certified, depending on how safety critical your system is. These are all going to feature in here. We might have specific organizational requirements at the implementation level. And what this means is you might have to follow particular coding styles or particular guidelines for how you implement your functions, for instance. And then the other side is the external. Right, we talked about ethics at the very beginning, and I hammered that home in multiple lectures how important it is. Well, here's where we codify them. What types of things do we have to consider for our system ethically? Right, and this can be a very, very high level topic. You may or may not have them in there. It depends on your program, right? But if you're building something like a phone application or a web application, what kinds of data are you collecting and what are you doing with it, right? So all those ethical concerns we talked about would feature in here. We have interoperability. Do we work with legacy systems? Do we provide APIs for other developers to query? Do we provide any kind of hook to, have our program integrate seamlessly with others? So we have this type of requirement as well. We also may have legislative requirements. So things that are specified by a governing body, right? Do we have to have any privacy requirements? So if we're handling European users, we have to follow GDPR. Or, whatever ends up happening with the Facebook stuff that's going on right now, are we going to have to deal with, what do we do with users' data? Do we go do deep dive into their daily lives or not? And then obviously safety, very, very important thing. How do we specify what is safe and what is not, right? Is it better to run into a wall or to hit a pedestrian if you're an autonomous car? These kinds of things, which are very hard to think about, we will codify them in here. RIP Facebook. Yes, I gave up Facebook a long time ago and I've been much, much happier. I still have one just to have it for work purposes, but being separated from that has made me so happy. Okay, so you have the high level now, right? Here is our tree of non-functionals. Now, when we have users or customers and we're trying to figure out what requirements we're writing for the project, they're going to tell us things that are horribly imprecise, right? So if I have a customer meeting and I'm talking to their product manager and they're telling us what we have to build, well, how do you want the system to look to your users? Well, we want it to be user-friendly. Thanks. Right? That's super unhelpful. We need very specific requirements that are going to be verifiable, that we have to be testable. Right? So earlier when I said they're kind of nebulous, they're very hard to check. When we are developing our non-functionals, we should write them internally in such a way that we can quantify them, right? So if their product manager tells us user-friendly, we have to take that and translate it into, okay, the buttons have to be a certain size, or we have to have alt text on every single image, right? Or user number of clicks should be minimized from page to page. System shall recover from a failure quickly. Okay, what does that mean? Quickly could be a millisecond, it could be 20 minutes. These are the kinds of things that we have to kind of nail down. So think of talking to a customer or whoever you're getting your requirements from. Pretend like you're talking to somebody who is not technical, right? So I know that you're all in computer science here, right? And you're probably the tech support person for your family, is going to be my guess. Somebody brings you a computer and says it doesn't work. Okay, well, why isn't it working? What's the problem? What are you seeing? You try to kind of figure out how we can get to what the problem actually is and then solve it, right? That's part of being a computer scientist, or whatever your path is. You're probably still going to have some kind of a technical bent. Same thing is here. User-friendly means nothing unless we quantify it. Quickly doesn't mean anything unless we quantify that. All of these types of things are going to be important for you in an analyst role. All right, we have 9 minutes left. Questions so far? Are everybody good? We're number 1. Thumbs up. Seems good. Awesome. All right, so here we have some examples for NFRs that have been defined for whatever company this is that I yoinked off of Google Images. What is this? Requirementsquest.com. There you go. And hey, they're a WordPress website. Employees shall be forced to change their password the next time they log in if they have not changed it within the length of time established as password expiration duration. It's a very wordy, non-functional requirement. All right, so this is security related. It's definitely a good example. There is some flexibility here, but it's still testable. All right, so I can write a test for this, and this would basically be, some kind of a almost a unit test, basically, where it'd be more of a user test. So let's say we're a Windows environment, and you go to log into your machine, and you get the pop-up, you have to change your password. Well, how do we know that? There is going to be a field in the Windows Server side of things saying this user has not changed their password in 100 days. And that is what was set for password expiration duration. We do have some flexibility here, but we have a named field that we can work with. All right, so just some examples for you to peruse at your leisure. But basically, again, these are still high level enough to be quality related, but they are testable. Right? The initial password may never be reused. That is something that we can test. Okay, so hopefully by now you kind of get the purpose of the different types of requirements, the different levels of requirements, and again, why they're so important to us. Now we can talk about the engineering side of things. And we're not going to get through the whole thing today, but the engineering process is where we actually build our formalisms into requirements, right? So engineering, again, this is going to be having a very rigorous process for defining these types of things. Last time we talked about consistency in our systems, right? Same thing applies here. Requirements should be consistent. So here we're going to have two activities. We're going to have the development side, where we actually create our requirements and we test them, and we make sure that they're good requirements. And then we have to manage them. So management is the other side of the coin, where it's effectively like configuration management, right? We have to have the technologies and the tools and the processes available to have our requirements live over time and be attached to other objects, have them be updatable, have them be tied to artifacts, things of that nature. So think of it like configuration management. The term management should make sense here. Why do we need both? Just to make sure that you're kind of on the same page as me, right? So we have to create them and we have to manage them. I just told you what management is, but why do we need both? Out of T. Any ideas? Well, he pulls up better TTV to get a good emote in here. There we go. It's not really possible to have a group of developers randomly creating functionality without some management bringing it all together. There you go. Yes. So the one key thing here too is that I haven't talked about this, so it's almost a leading question. Added structure, yeah. So let's structure our process, absolutely. We will have to go through a phase where we make sure that we don't have any redundant requirements or poorly defined requirements. Right, so we might create that big software requirements spec. We'll put it into our config management tool or requirements management tool, whatever we have. We're going to have to go through and make sure every requirement is correctly written, that it's specifying exactly what we want it to, that we don't have any redundancies or maybe missing information. And you can't really get to that stage without having some kind of an oversight, basically any kind of an overhead tool. So both of these are very important here. I guess what we'll do is we will stop there, because otherwise we're going to get into a whole other thing. Anybody have any questions from today? Any questions on the homework? Anything you want to talk about? Complaints? Comments? Added structure, okay. Other than that, what's the proper markdown for a section and subsection for the homework? Let's take a quick look at that. That's a good question. I'm just going to pull up the homework here. All right, proper markdown for a section and subsection. So are you talking about the personal repository or the team repository? Yes. Yes to both. Personal. Okay, so this is what I have right here. Right, so a section heading, that's where you have your pound sign. So this would be like, I'm not going to go through the whole thing. Hey, I missed that. Did I give you guys the markdown formatting guide? I guess I didn't. 1 second here. Markdown guide. String markdown. All right, sorry, I thought I sent this out to you. If I didn't, then there we go. So sections are prefaced by pound signs. So if you do 1 pound sign, that's like a big heading. 2 pound signs would be a subsection. 3 would be a subsection. So it's just like pound, pound, pound. So this would be like subsection 1. With Markdown, it's important to have a space in between lines. Yeah, exactly. So like if I'm gonna do section heading, so it's like Eric Fredericks, and then I have a space, and then I'd have like bullet 1. Oops, that doesn't format really well. Basically, I've got like big spaces, so let me fix this here. Section 1, blank. Just gonna put a dot. Ignore the dot. Bullet 1, blank. Chat's not updating anymore for me. So basically, bullets are going to be asterisks. Links are going to be, I would look at the markdown guide, but it's basically like a bracket, and then a bracket around the text you want to show, and then parentheses around the link. I always get those backwards, but Yeah, the link I sent should hopefully be helpful. And if you're still not sure, look at the README in the team project repository. I have the example README file there. But yeah. And if you're struggling with this, feel free to pop by the office hours and show me what you're working on too. Alrighty, other than that, I will see you on Monday. We will wrap up. When is the initial project proposal due? So that's due with your homework here. So that is that's due Tuesday night. Yeah, 29th. Thank you. That's why I gave you 2 weeks to work on this. Easy. Absolutely. Should be. I like to give more time with these kinds of things. Honestly, you probably could have gotten this done, banged it out in a week, but there's always going to be technical problems that crop up. So I like to give you more time to work on some of these. So anyway, I will see you all Monday and hope you all have a wonderful weekend. Should be hopefully beautiful outside. Enjoy our last summer. Second summer, I suppose. Yay. Bye, everybody. Except for the rain. Oh, rain's a good thing.